Hi everyone. So today we'll be looking at another interesting 5G open source project which I just stumbled. Will I say by luck? I just saw on UA Sim when Guillaume, sorry for not pronouncing that well, when he made a commit. So I just decided to check his profile. Then I now realized that he's actually working on an interesting project. So this project is called Elacore or Elacore, whichever way you want to pronounce it. And this is strictly for a private 5G deployment. So and why I said strictly private is because this is a single binary that gives you everything end to end for your 5G core, right? And the reason they are doing this is to make it very easy for a private deployment of 5G core. And this will be, if you see here, it says it's lightweight, like you just need as little as 2 CPU cores, 2 gig RAM, 10 gig of space. And surprisingly enough, it has a UI, a good UI, I would say, and also it has APIs, right? So that is a major big plus to the project as far as I'm concerned. And it's actually being used. It's actually using other projects underneath, right? So you can see here that they are giving a reference or acknowledgement to the ATA project, which is the Open Networking Foundation, and then the EUPF, which is one of the recent 5G UPF project that is dedicated to just creating a UPF based on eBPF, and then also free 5G, which I believe most of us will already know about. So I set out to give this a trial, right? So even though the aim here is actually that you should be able to set this up on a single PC, right? To make it easy. So like I said, the emphasis of the project is not to make it complex, because it's private deployment. So if it's private, you don't need to you might argue whether you need all the different components split across the different functions, right? Like having a separate AMF, UPF, or whatever. But this project actually combines everything into one box, just like if you not the closest that I will see that I will relate it to would be the Magma project by the Facebook project. So you can see in Magma they're combining some functions all together into some box, but here you only have a single deployment that handles all the 5G core functions. So what I've gone ahead to do is to just have some M charts, right? So here you see that we have the UA Sim, we have the router. Currently, from the docs, it says that the LR core cannot do NAT by itself, so that's why you have a router here, right? And then we have a couple of multis interfaces that we'll need. So if you look at the LR core here, you see that since it's eBPF, so that's why you are mounting this part right from your host. And then another thing I did differently is to handle the UE IP pool routing towards the router here. So what I did was to use a source routing, right? So what I did is to create a new IP route table and then add a rule from the UEIP pool. So if any traffic is coming in from the UEIP pool, it's going to route it. It's going to use this table, and then this table is now using the router here as its default gateway. So it depends on how you want to do this. This is one way what I to do is I've not played around with the VRF, whether it supports VRF, or another way you could do is to just remove maybe the default route that comes with the pod, right? But that's not really ideal, and it can break a lot of things, especially if you want to communicate to the pod from other pods or thereabout. So that's why I'm using source routing, right? And if you see the values.yaml file, you actually see that these are the Multus configuration. So you will see that the router is actually using the UPF as the next up for the UE IP pool. So you may not see the UE IP pool here. It's because I'm using templating in in Elm. So you see here that I'm saying that if there is route, which is only one of the NAT that will have the route function, which is the router, right? So I'm directly injecting. So this is already set up in the values.yaml file also. But then you can now see that I'm using the destination, which is the UAIP pool. So Multus will create this route table for us directly instead of having to set it here. It's a choice. You could also set it here directly here, right? And it will still work. But if you want to use Multus end to end, then you will you can just and then we are doing the NATing right via IP tables, and the config is relatively easy compared to what like your normal 5G stuff. So you have the N2, N3, N6. So like I said, since it's a one box solution, you don't see the N4 interface, for instance, right? So the SMF is inbuilt, the UDM and all the likes. So because these are the interfaces that you need to actually communicate both on the ingress and the egress, right? So this needs for you to connect to your radio on the N2 for the AMF, and then the N3 for the data plane, right? Also goes to the radio, and then the N6 goes towards the router. Then you have the API also, so you have the option to actually select to use an API interface specifically for the API. So this is a good way to to separate your interfaces as per their functionality, right? So you have an API which can be also be called your OAM interface, right? So that's where you do your operations and administrations function. So we have all the Helm charts here. So what we'll go to do now is to do an install. So what I've done here is, so if we do a watch and then see how it will be created. So one other thing is the IP where I'm using for the API, which is also the web UE interface, is this. So that means we need to connect to the UI using this IP address. So the pods are up, so we can go to another. So if I refresh this, I should have. So when you refresh this, it tells you to create the first user. So I could use my email. So once you are done, you have created the user. Then you log in. Okay, so let's see. Did I make? Okay. Now, once you are logged in, you see the UI. Like I said, it's a good UI. You don't have the radios yet, right? You don't have the any active session. So what you do, if you want to also follow through on the docs, if you go to the docs link here, you see the running end to end. So though this is not, they're actually using Snap to install, but you can also follow through. So that's exactly what I also follow through here. So the first thing is you create a profile. So you go to the profile. So your profile is what will we'll create like the IP pool, the DNS, the MTU. So what I first of all realize is that this has to really match with what you have in the documentation. So I assume maybe this is, like I said, the project is still in beta. So I think some of these values are still hard coded and you need to follow them through. So once you create that, then you create the profile first, and then you create a subscriber. If you are used to other projects like Open5GS, you see that it's a little bit different, right? So you just create the UE or the subscriber directly, right? But yeah, you create profile, right, first, and then you now create subscribers. And then when you create the subscribers, then you now have to select the profile. So another cool thing here is that you could just generate an IMSI, right? So, and then also generate the the key. So what we'll do is, once we create this, we are going to replace it also in our Helm chart, and then sort of just overwrite what we have for the URN sim. Because if you see here that the URN sim is actually running, but it's not starting any process yet. So if we go to the URN sim, and then we go to a shell session, so we see here that we have nothing there, or we don't have any URN sim process running. So we'll click on create. So once we click create, so what we can do is click the view here, and since we have a IMSI created for us, we can now go to our Helm chart and then replace the IMSI with what was created. So you see there, then also you could replace the key, and then also the OPC. So we confirm if everything matches right. So the MCC MNC, then 995. Okay. So what I'm going to do now is to go into my charts on my system, then replace the values.yaml file here, exit out from here, then do the upgrade again, and we'll wait for the config map to kick in to show in the, but before then we can actually see if it has reflected here. So we see, has it reflected? No. So we have, where is the IMSI? So this is 22, so it has not reflected, but after a while we should see that. But before then we can start the Gnode B process. So this is the URN sim Gnode B, send that to the background. So we see that was successful. So if we go back to the dashboard, we'll see that we have one radio, and if you go on radios, you see that this is showing as URN sim, and this is the IP that is connecting to it. So what is next is to connect the UE. So, but let's see if the UE has reflected. Okay, now it has reflected, so you can see that the IMSI now shows up with what we have. So if everything has been set up fine, you should have this also working. So we can also send that to, okay, sorry, we need to use --config. Okay, so we are getting some authentication error, yes. So let's see what could be wrong. 947. Okay, so let's double check what we have. So under subscribers, we see, okay, so another thing I've noticed, maybe I will raise it with the the project stuff. So sometimes if this sequence number is not on 3, sort of, let's see, can we? No, we cannot. So we can let's delete again, and let's just make sure that it's on 1. Let's see again. Okay, so let's do it again. Although I'll check through the config, the documentation again to see how, if that affects it. So we have the IMSI, then we have the key, then the OPC. So let's replace that again, and then let's apply it again. Let's do the cut again to see if it's as reflected. No, it has not. So we see that the IMSI we have is 6277. So let's see. Okay, still. Yep. So what we can do is just do a watch and see when it changes. So this is just your normal Kubernetes stuff. So when you update your config map, and if it is provided you don't load it as a subpath, so you should see the file also updated in your mounted file within some few seconds to some minutes. You will see it updated. So let's wait for that to get updated, and then we'll try to initiate the UE. Okay, yeah, so it has updated now, so you can see the 6277. Now let's give the UE try again. Okay, it's still not working. So let me give a pause and let me check to see what could be wrong. Alright, so I think there must be an error there must be maybe a bug, most likely in the LR project, but I'll raise it up with the project. So but what I did was to I see that the sequence number kept changing. So what I did was just to put it at starting 22, right? So when you click the create, so I changed this, instead of it starting from 1, I changed it to 22, right? And then if you see the IMSI, so the IMSI is 938809, so that also maps with what is there. So but after I did that, it was working. So let's if we do a cut, let's do the cut. So you see this IMSI matches out, and then the key and the OPC, right? So if we initiate the UE again, so you see that now the UE is able to come up with an IP. And if we go back to the dashboard here, we see that we have subscribers 1 and we have active sessions 1. So another interesting, if you start pushing some traffic, you will see that these numbers tend to it will be giving you it will be reflecting that there is traffic going through the 5G core. So an example of this is to use a sample test file. So we are going to use wget, but first of all, let's see so we see the UE sim 0 has been, that's the tunnel interface. So if we do a ping to the internet, So we can see that that works. So that means the connection from the LR core to the router and then to the internet is working. So now we can do the wget also to see if we can see some of the traffic coming up, showing up on the UI. So I don't think the wget is installed by default here. So what we can do is to do so we'll let that run, and then we'll now go back to get that file and see how it shows up as part of the metrics. So also I think there is the metrics are being picked up, like Prometheus, right? So because I see that they mentioned something about Prometheus. So let's see wget. I need to see the bind. Okay, so we need to bind it to, let me show. So we need to bind it to an address. So the address will be the interface, the tunnel interface IP. Let me grab the link again. So now this is going through the 5G core. So if we go back to the LR core, we'll see here, you can see that the throughput is, it's reflecting what you have here. So yeah, the throughput is a bit low here because if you check the config, we are actually using the generic mode for the eBPF. So I want to show where's that. Yeah, so we are using the attach mode for the XDP, which is the eBPF. The EUPF, we are using generic, right? So if we are to use like the native attach mode, and most likely not use, if you use the URAN SIM on a dedicated VM, then we might get a better throughput, right? So but for now, this is just for demo purposes, right? So we see here that actually the setup works. So the only issue that, like I said, that I encountered was the sequence number. So something that I'll have to check whether it's with the LR core, or maybe something on URAN SIM that might be the cause. So usually I don't get that error. Sometimes I think maybe it's maybe it just happens once in a while. So by and by, that's what we have here. So like I said, a nice UI interface, right? So you see, and I think this might be the first project, if I'm not mistaken, that has something very, very simple to make use of. So from the operator side, you can see something that shows you exactly how your private 5G stuff is doing. Like I said, you have the radios, the subscribers, and like I said, I'm not using the route here. I'm just using it directly with the from the M chart with the source routing. So can give it a try. Check the documentation. And an interesting thing here is that there is a discussion going on like adding HA stuff to it, right? So which I think will make this also interesting. So far I think this is still in the planning phase. So you can see they want to like both the control plane and the data plane. They want to like scale them out so that you don't have one point of failure. So I made I commented also on it to see that, okay, yeah, we can make use of log CLB there also. LockCLB, if you have taken note, also has a stateful feature for the N2 interface. So that means that it's more telco aware, and you can use it to as a load balancer for the NGAP protocol. That's to sit in between the control plane. So this is one part that I'm interested, I'm seeing, to see how it pans out. And also the maybe the NAT also, right? So if you have the NAT implemented, that might be a good thing. But then it says that it might decrease performance. But in most cases, you might definitely have the NAT being done on another device, maybe on the firewall or on another router. So that's that with what I've been able to come up to see how this project, the LR. So I think it's interesting, and let me know your thoughts and comments, and I'll see you in the next one. Thanks.